Have you ever looked at a massive power plant or a sprawling oil refinery and just wondered, how on earth does something like that get built? Well, you've just stumbled into the world of EPC. It stands for Engineering, Procurement, and Construction, and in this explainer, we're going to pull back the curtain on the blueprint that builds our modern world.
So let's just start with that huge question. I mean, really think about the mind-boggling complexity of a project like a new nuclear power plant. We're talking thousands of workers, millions of individual parts, and billions with a B of dollars on the line. How do you possibly keep all that from spiraling into complete and utter chaos? Well, that is the exact problem that EPC was created to solve. So what exactly is EPC? At its heart, it's a model designed to wrangle all of that immense complexity using a surprisingly simple idea: a single contract for a very complex world. Okay, so EPC stands for Engineering, Procurement, and Construction. But honestly, the magic isn't in those words. It's in the concept that a single contractor is responsible for the entire thing, the whole shebang. From the very first sketch on a napkin to the moment they hand over the keys, one company is in charge. That is the core idea that makes this whole thing tick.
Here's a super simple way to think about it. Imagine you're building a house. Now, you could hire an architect, then go find a separate plumber, then track down an electrician, and try to make them all work together. It's a headache, right? Or you could just hire one master builder who handles everything for you. EPC is that master builder approach, just for projects the size of a small city. So let's quickly break down these three pillars. Engineering is the brains of the operation, all the technical plans, the blueprints, every single detail. Procurement is like the project's massive shopping list, going out and sourcing everything from gigantic steel beams to highly specialized software. And finally, construction is the brawn, the part you can actually see, the physical building of the facility. The EPC contractor's job is to weave all three together seamlessly. Okay, so now let's look at how this all works in the real world. We're going to walk through the typical project lifecycle to see how an idea goes from just a blueprint to a fully functioning reality. This journey isn't random. It follows a very clear logical flow. It moves through these distinct phases that are all completely interconnected. So let's break down exactly what those are. It all kicks off with initiation and something called FEED. That stands for Front-End Engineering Design. This is where the client and the contractor basically agree on the big picture of what's being built. Then you dive into detailed engineering, where every last nut and bolt is specified. After that, procurement fires up and the team starts ordering everything. Then comes the most visible part, of course, construction. And finally, you get to the handover. This includes a super critical step called commissioning, where they flip all the switches and run all the tests to make sure everything works perfectly before the client officially gets the keys.
All right, now we're getting to one of the most important concepts in EPC. It's all about a fundamental trade-off. The client gets certainty, but someone else has to take on all the risk.
You can see why clients, the owners of these projects, absolutely love the EPC model. You get what the industry calls one throat to choke, a single point of responsibility. No finger pointing. You get cost certainty with a fixed lump sum price agreed to right at the start. You get schedule certainty with a hard deadline. And maybe the biggest benefit of all, you transfer the vast majority of the project risk right onto the contractor's shoulders. Which, of course, leads to a pretty obvious question. If the client is all safe and sound, protected from cost overruns and delays, who's left holding the bag when things inevitably go wrong? Where does all of that risk actually end up? It ends up right here, squarely on the shoulders of the EPC contractor. This table lays it all out. Errors in the design, that's the contractor's problem. A key supplier is months late with a critical piece of equipment, contractor's problem. A streak of bad weather shuts down the site for a week, again, the contractor bears that financial pain. The only major risk the client usually holds on to is if they decide to change the scope and ask for something new midway through the project. So we know the how and the why, but where do we actually see EPC in action? Well, the answer might surprise you. It is literally powering the entire global economy. And that is not an exaggeration. The size of the global EPC market is almost impossible to wrap your head around. In 2024 alone, it's estimated to be worth $2.5 trillion. Let that sink in. Trillion. This is an absolutely colossal industry. So where is all that money going? This chart shows that the energy sectors are, without a doubt, the dominant players. Oil and gas takes the biggest slice of the pie, followed closely by power generation and petrochemicals.
And it makes total sense. These are exactly the kinds of industries that build those massive, complex, high-risk facilities where the EPC model really shines. And these aren't just abstract categories on a chart. These are the real-world projects that define our modern lives. Every time you drive by a refinery, see a new solar farm pop up, or hear about a massive new bridge or a liquefied natural gas terminal, you are very, very likely looking at the result of a complex EPC project.
For our last section, let's get practical. With so much money and so much risk on the line, what are the key ingredients that separate a successful EPC project from a complete and total disaster? Well, success in EPC starts long before the first shovel ever hits the ground. Having a crystal clear scope definition from day one can prevent a staggering 80% of future disputes. Beyond that, success really hinges on strong leadership, being proactive about managing risks, and fostering transparent communication. And more and more, it also depends on adopting new technology like BIM, that's Building Information Modeling, which creates these incredible 3D models of the entire project to boost efficiency and catch problems early. As we wrap this up, I want to leave you with this final thought. It's easy to get lost in all the contracts and the risk management, but what we're really talking about here is monumental. As this quote says, EPC projects literally build the world around us. They create the systems that deliver our power and our fuel. It's the hidden engine of modern life. And that really leaves you with a question, doesn't it? What incredible new infrastructure will the next generation of EPC projects create for all of us?